E equals mc squared is one of the most famous equations in science, created by Albert Einstein in 1905 as part of his theory of special relativity. At first glance, it looks simple, but it completely changed how we understand the universe. The equation says that energy, E, and mass, m, are two forms of the same thing, connected by the speed of light, c, which is about 299,792,458 meters per second. In words, it means that a small amount of mass can be turned into a huge amount of energy because the speed of light squared is an enormous number. The c squared acts as a conversion factor, showing just how much energy is hidden inside even tiny bits of matter. Einstein came up with this idea by thinking about how energy and mass behave when light is involved. The equation can also be seen in another, slightly more general form. E squared is equal to pc all squared plus mc squared all squared, where p is momentum. For an object at rest, its momentum is zero, so it simplifies neatly to E equals mc squared, which tells us the energy something has even when it isn't moving. To see how powerful this relationship is, imagine converting just 1 kilogram of matter into energy. Using the equation E equals mc squared, that's 1 times 299,792,458 squared joules, which equals about 89,517,873,681,764 joules, or around 9 times 10 to the 18 joules. That's roughly the same amount of energy released by 21 million tons of TNT. Even 1 gram of matter, about the weight of a paperclip, would release about 21,000 tons of TNT's worth of energy if fully converted. This shows why nuclear reactions, which convert only small fractions of mass into energy, are so powerful. In the sun, nuclear fusion combines hydrogen atoms into helium, and the small amount of missing mass becomes energy that keeps the sun shining. The same principle is behind nuclear power plants and atomic bombs, though controlled very differently. Many people misunderstand the equation. It doesn't mean mass turns into energy just by moving fast or that objects become energy. Instead, it shows that mass itself is energy in a dense, concentrated form. It also doesn't break any conservation laws. It simply unites the conservation of mass and energy into one law, the conservation of mass energy. You can think of it like money in two different currencies. Mass and energy are interchangeable, just measured differently, with c squared being the conversion rate. The equation's significance goes far beyond physics labs or nuclear plants. It reshaped how scientists think about everything from how stars work to how the universe began. In particle physics, the mass of protons, neutrons, and electrons corresponds exactly to how In particle physics, the mass of protons, neutrons, and electrons corresponds exactly to the energy needed to create them. In cosmology, it helps explain how the early universe converted pure energy into the particles that make up all matter today. Even in everyday life, the idea that mass stores energy is what makes chemical reactions, electricity, and even the warmth of the sun possible.